Okay, so we will wait for her to start, and for the time being, let's discuss some questions. Okay, so I'm writing the questions here, 5 questions here. You have to answer it in the chat box. Okay, only one word or few words answer. Okay. You can understand what I'm writing.
Yes.
Okay, there are 5 questions. Okay, has Jadwa joined?
No, sir.
Okay, okay. He has still not joined. Okay, first one is 37 degrees Celsius. Okay, no. Minus 10 to 110. Good. Yeah. Fourth one. Explain fourth one also. By the way, when your summer vacations are starting in school, Mafaz?
Sir, 25th June.
25th of June. Okay. It can break. Very good. Let me call for Jadwa. She has not joined us still now. Okay. Temperature. All right. Very good. Very basic questions. And your answers were also correct. Okay. All right. So far in our discussion, we were talking about heat. Okay. And the hotness and coldness of a body, that is called temperature of a body. And to measure temperature of a body, we have got different types of thermometers. The one which is used for measuring human body temperature, that is called a clinical thermometer. And what is the temperature of a clinical thermometer, by the way? It is from
Sir,
37 to, yes,
sir, 35 degrees Celsius to 42 degrees Celsius.
35 degrees Celsius to 42.
Yes.
Yeah, 35 degrees Celsius to 42 degrees Celsius. That is the range of the clinical thermometer. And for other purposes, for in laboratory use, we have got laboratory thermometers. And nowadays we have got digital thermometers also. Okay. Now the chapter is divided into several topics. The chapter heat. So first topic is the topic heat itself. Okay. So heat, it is a form of energy, right? So heat is basically a form of energy. And to measure this form of energy, we cannot just rely upon our senses, right, Mufas? So we have to take help of thermometers. Okay. So heat is a form of energy, and it makes a substance hotter. What did I say? It is a form of energy and it makes a substance hotter. A substance hotter. And can we see this form of energy? Can we see heat?
No, sir.
No. So we also say heat cannot be seen by us. Heat cannot be seen by us, right? So we can feel this heat by the temperature effect. The question arises, what is this temperature effect now? Yes,
Yes, sir.
we can feel it by temperature effect. By temperature effect. Now, what is this temperature effect? Like a body produces some amount of heat. Okay, a body may not produce enough amount of heat. So the temperature effect here refers to the hotness or coldness of the body. Some bodies are hotter, some bodies are colder. So this difference in the heat output by the body, that is measured in terms of temperature. Right, Mufaz?
Yes.
Okay. So you see, when heat is given to a substance, its temperature, it's obvious it is going to rise. And when heat is taken away from a substance, its temperature is also going to fall down. Okay. So next thing is, as you see here, I have mentioned after heat, it is hot and cold temperature. Hot and cold, that is temperature. So in our previous class, we already talked about measuring thermometers, types of thermometers. Okay. So the chapter has been divided into four major sections. What are they? First section is temperature. Then how do we measure this temperature? Then types of thermometer, right? Then the fourth and the biggest section of the chapter is transfer of heat. How does heat gets transferred from one place to another, from one medium to another? Okay, so heat, just to give a brief introduction, heat can travel in three ways. Okay, it can either transfer via conduction, via convection, or by radiation. Okay, so the first two ways requires a medium to travel, while the other two does not require a medium to travel. While the third one, that is radiation, it does not require a medium to travel. Okay, so we will begin with conduction. We will begin our discussion with conduction, and here we will talk about how heat transfers into solids and what are the good and bad conductors. Okay, and why we wear woolen clothes in winter and not cotton clothes, right? Because there you will get to know that even air acts as an insulator, as a bad conductor of heat. Okay, although heat travels via air, okay, heat can travel via air also. In the convection, you will get to know about that. That is, in convection, we'll talk about how heat travels in water and air, then water, sea breeze, and land breeze. So, how there's a role of air in making us feel warm during winters. Okay. Then the last topic of the chapter is radiation. That is how heat travels from sun to us. Because technically, you see, there is just vacuum between Earth's atmosphere and in between sun. So there is no medium. Neither you have solid medium, neither you have a liquid medium there. Neither it's air. So how heat is a traveling from sun to us without a medium in the vacuum. Then we will talk about what are the absorbers and emitters of heat radiation. All right. Okay. So in the previous class I wanted to discuss a activity. I have taken a activity here. Okay, so here in the activity it says that take three balls A, B, and C. All right, Mafaz, can you read it? If it's visible, read this one. Read this activity.
Take three balls A, B, and C. Put cold water in bowl A, hot water in bowl B, and lukewarm water, slightly warm water in bowl C. See figure 1. We dip our left hand in cold water in bowl A and the right hand in hot water in bowl B. See figure 1A. Keep the hands in this way for about 2 to 3 minutes. Now take out the hands from bowls A, B and dip both the hands quickly. Lukewarm water in bowl C.
Yeah,
See,
just keep on reading.
see figure 1B.
Okay, actually I haven't taken the figure here, that's why I'm drawing it. Okay, so here we have taken three balls, ball A, ball B, and ball C. So what is being done here, that in ball A cold water has been taken, in ball B hot water we are taking, and in ball C we are taking lukewarm water, that is neither too hot nor cold, that is normal water. Lukewarm means water having normal temperature. Okay, so what we are going to do, we are going to dip our left hand in cold water. In the cold water we are going to dip our left hand. This is your left hand. Now in the second ball that is containing hot water, it shouldn't be too hot that you get injured, just normal hot water. So you dip your right hand in hot water in ball B. Okay, now keep both the hands in the way for about 2 or 3 minutes. Keep both of your hands dipped in the ball for 2 to 3 minutes. All right, Mafaz. Now take your hands out of these balls, out of ball A and ball B, and together put your hands in the ball C that is containing lukewarm water. So you will put your hands, okay, in ball C, right? This is ball C. And what is the temperature? It's normal temperature. It's neither it's too hot, neither it's too cold, right? Now, uh, now what we are going to observe here, you see, this left hand, you had put it in which water? In cold water. Okay, and this right hand, it was put in hot water in ball B, right?
Yes, sir.
So what you will observe here, that your left hand will feel warm. Left hand, it will feel warm. It's an interesting activity you can perform at home. Very simple activity you can perform and check whether it's true or not. In fact, it is true. You can experience it yourself. And your right hand, which was dipped earlier in hot water for 2 to 3 minutes, it will, in this hand, you will feel cold sensation. You will feel cold. Now, here did our sensation, here did our senses work? Were our senses correct here? Look,
Yes, sir.
sometimes our sense of touch is not reliable in telling us whether the given medium is hot or cold. Like I know that this ball C containing lukewarm water, the temperature of the water is normal, although I am experiencing different temperature in my different hand. In my left hand, I experience the water to be warm. In my right hand, I am experiencing that the water seems to be colder. Why is it so here? Because our sensationary organ is not always reliable in telling us whether the object is really hot or cold. All right, Mufaz.
Yes, sir.
Okay, so here it is. Here we debunk this basically, that we cannot rely on our senses always. Okay. Now, what is actually happening here? What is actually happening here? Why why we are experiencing such different behavior is the reason that heat travels from a hotter object to a cold object. So our left hand was what? It was placed in cold water, right,
Yes.
Mafaz? So it is cold, and in comparison to our hand, the lukewarm water is little bit warmer. So heat will transfer to our hand from this lukewarm water. Hence, it will feel warm, right, Mafaz?
Yes, sir.
And same is the case with the right hand, which was earlier placed in a warm water. So it is warm now. The hand was warm, and in comparison to our hand, the temperature of lukewarm water is lesser. Hence, heat will flow from our hand to the lukewarm water. Hence, we will experience coldness in our right hand. Got this. So this is what was happening basically in the activity. Okay. All right. So far we have talked about all these things. Okay. So we were talking about transfer of heat, right? Transfer of heat, that heat flows from hot region to cold region due to transfer of energy from one molecule to another. We know that. So see in this figure, heat is transferring from a warmer object to a cooler object here. Okay. And modes of heat transfer are basically three: conduction, convection, and radiation. We were talking about conduction. Okay. Now what did we discuss about conduction? It is the mode of transfer of heat in which medium?
Sir, in solid.
In solid. Okay, what else you know about conduction from our previous discussion?
Uh, sir, it goes from one part to another part.
Yeah, it can flow from one part of the object to another part, or from directly one object to another if they are placed in touch. Okay. Okay, so here we have placed an object above the candle, and you see one part of it became hotter, and basically this heat was transferring from one part of the material to another part, right?
Yes,
Okay.
sir.
So this is the transfer of heat in two different solids, or from one part of the solid to another part, is called conduction. Okay. So now you see, based on how good heat can transfer from one object to another, or in an object, the materials have been divided into two categories. Okay. One are those materials which are good conductors of heat, and another one is those objects which are not good conductor of heat, right? So conduction, conduction is the transfer of heat from the hotter part of the object to colder part of the object. When I say object, I specifically mean solid objects.
Yes, sir.
Okay, and one more thing, that conduction is not necessarily going to take a place in between two solids only. Like you see, if I were to place, uh, let's say I have got two objects in contact with each other. One is hotter, another one is colder. So there is going to be transfer of heat. Okay, both one is solid here. But let's say if I bring this hot rod in contact with water, will there be no transfer of heat?
No, sir.
No, no, there will be transfer of heat. No, this is water. Okay, this is a solid material. So when I dip this solid rod, which is hot, in this water, so in this case, the mode of transfer of heat will change because this is a liquid medium. So there you will experience that it is convection. That is convection. Okay. Okay. Let me take a figure here for a proper depiction. Okay. Are activities performed in your school? Do you guys get to perform? Do you get to perform activity in your school, Ahmed? Mafaz?
No, sir.
Okay. Teachers do not take you to the laboratory.
No, sir.
Okay. Okay. But there must be a laboratory section for junior classes as well, no, in your school.
Yes, sir.
Okay. Okay. So you guys must ask the teacher to take your classes to laboratory section as well. Yeah. Because science, you got to feel it. You got to experience the things. Okay. It's a very practical subject, right?
Yes, sir.
Yeah. See, you can see the screen.
Yes, sir.
Okay. See here. All three different modes of transfer of heat we can observe here. Right. Study the figure here. What is happening? The water is being boiled on a gas burner here. Okay. So if you were to touch the handle of this, if someone was to touch the handle of this utensil here, he will experience that it is colder. It is made up of metal here. Okay. And the heat is transferring between the adjacent molecules of this handle via conduction. Now, come to the liquid material which is being boiled here. So you see, convection current is being generated in this. And due to convection, all of the liquid medium is getting hot here. Right. So when we will come to convection, we will discuss that as well. And see here, via radiation, there is emission of electromagnetic rays here. Right. So there is emission of electromagnetic rays that is responsible for radiation here. So all three things can be experienced here. Okay. So as I was talking earlier, that if you take a beaker and put in this beaker a hot rod, okay, and the beaker is filled with water, so in that case, the mode of transfer of heat will be convection. From this rod to this water, the mode of transfer of heat will be convection. Right. Okay. Now, based on the amount of heat transfer, or based on the material, based on the based on how much heat is transferred by a material, we categorize them into two parts. What are they? Let's move fast. In two parts. So first one is the good conductor. What are some examples of good conductors?
Sir, metal.
Yeah. So these are objects that easily allows heat to transfer through it. That easily allows heat to pass through it. Can you name some of the metals which allows heat to pass easily?
Sir, iron.
And
Copper.
and that allows heat to pass easily. So some of the examples as you mentioned, it's copper, aluminum as well, aluminum, iron, brass, etc. Okay. Now another type of material will be that will not allow the that will not allow heat to easily pass through it. Like if you see the handles of utensils used in the kitchen, they are normally made up of rubber or plastics. Otherwise, if they were made up of metals, we would injure ourselves. Okay. So they are called the bad conductor, or they're also called insulators. Okay, so remember the another name of bad conductors of heat. So they are called insulators also. Okay, so what are insulators? These are those materials that does not allow heats to properly pass through them. Right.
Yes, sir.
So those materials which do not allow heat to pass through them easily are called what? Insulators. Right. Okay. What are some examples of insulators?
Sir, rubber, plastic,
Rubber, plastic, and what else? Bricks. Can you think of some other examples?
sir,
Wood. Wood is also not a very good conductor. Wooden materials. Okay. Or the clothes. Clothes are also bad conductors of heat. Or let's say wool. Wool is also a bad conductor of heat because the the very purpose of wearing clothes made up of wool during winter is that it does not allows air to escape through it. Say this is your skin, okay, and this is the wool cloth over it. Okay, just sideways view. Okay, so let's say this is woolen cloth over the body, and in between woolen cloth and the skin, this is skin of a human body. So there is air in between it. Okay, so between the woolen cloth and the skin, air is trapped. Woolen cloth does not allow the air to escape through it. Plus, heat will also not escape via the woolen cloth. While if someone wears a cotton shirt during winters, heat will easily escape through the cotton clothes due to fine gaps between it. So that's why woolen clothes are weird during winters, right? Okay.
yes,
Now, if you were to talk about the liquids and gaseous substances, are they good conductor of heat? Yeah. Any idea?
mm,
Look, in general, whether you talk about water or air, they are also poor conductors of heats. Okay, so they will also be put in the category of insulator. All right, Mafaz.
yes, sir.
So in general, liquids and gases are also poor conductors of heat. Poor conductors of heat. Right. Okay. So as I already told you that the materials which trap air, okay, like the woolen clothes, what it basically does that since the air is a poor conductor of heat here, so it will not easily allow the heat to pass through it. It will hold the heat. That's why in the winter season, woolen clothes are used. Okay. Okay. Now moving on, there are some good uses of these insulators. Okay, like if there was no insulator in nature, suppose if there is no insulator in our nature, so cooking would have been very difficult. because whole of the utensil will be very warm. And how do you hold the handle of the utensil? Okay, so good conductors, they are used to carry heat very quickly. Okay, while the poor conductors are used to stop them from going with where it is not wanted, right? So if you have a pan here, okay, you would want this pan to be very good conductor of heat so that the food gets cooked in time, while you want the hand to be a good conductor of heat because you will get your hands burned. So you use a insulator here. What could be this insulator made up of?
Rubber, plastic.
Wood, plastic, or rubber? Mostly it's rubber and plastic, right? Okay, what are some other good uses of these insulators? Can you think of some other examples?
Uh,
Yes.
hmm,
There are some other uses of all there are some other uses also of these insulators. Okay, almost all the metals which gets hot, which are in some kind of uses. Okay, like whether you see a car. Okay, so the handle in a car used to open or shut down the door. Okay, that is also made up of some insulator. Okay, and what are some good uses of the good uses of conductors?
sir, for cooking.
Yes,
For cooking, sir.
for cooking. Another example is the mercury metal, which is used in the thermometers because it is a good conductor of heat, right? Okay, and you see the handles of so many different cooking utensils. It is made up of a soldering iron. Okay, so soldering iron is what? It is made up of wood or plastics because wood or plastic is a poor conductor of heat. Okay, so the wooden or plastic handle does not conduct the heat of hot soldering iron to our hand, so that we do not get damaged, so that we not burned our hands. Right. So now the next question is let's discuss again this thing in detail. Why we wear woolen clothes? As I mentioned earlier, that this is also part of the chapter that why we wear woolen clothes in the winter. Okay, so woolen clothes, as you know, that keeps us warm during cold winters. Okay, look, the whole thing happens like this. Wool is a poor conductor of heat. We know that, due to which woolen clothes traps the woolen clothes stops the flow of heat from our warm body to the cold surrounding. Okay. Now, moreover, you see there is air trapped in between the fibers of the woolen cloth. The air is trapped. Let's say this is a close look of the fibers of a woolen cloth. Okay, and let's say these are airs. So air is trapped in between the fibers of this cloth. And air, as I already told, it is also a poor conductor. That is, it is also an insulator, right, Mafaz? And woolen cloth, this itself is a itself is a insulator. Okay. So what happens? The air trapped in the fibers of the woolen clothes also stops the flow of heat. The woolen cloth, it is already acting as an insulator. Now the air which is trapped between the fiber particles, between the fibers of this cloth, that is also acting as an insulator, and that also stops the escaping of heat. So there is nowhere left for heat to escape. Heat is almost trapped between the woolen cloth and the skin of the body, right? Normally, you see, clothes have tiny pores. Clothes which we wear, if you observe them carefully, they have very tiny holes in them, very tiny holes. If you see example of a cotton cloth, okay, if you observe it using a high power magnifying glass, you will see that they very tiny tiny pores between the between the cloth fibers. Okay. Similarly, if you see a woolen cloth, there are holes between the fibers, and in that hole also the air is getting trapped. The air particle gets trapped, so there is nowhere left for heat to escape. So this is how woolen clothes keeps us warm during winters. Got this?
Yes, sir.
Okay. So now do tell me one thing, like if you're given the choice in winter of using either one thick woolen blanket or two thin woolen blankets joined together, which one will you prefer?
Sir, no, two thin woolen blankets.
Two thin woolen blankets. Why? Because there will be two layer of air trapped within the blankets, right? Because the two thin woolen blankets when joined together will have a layer of air trapped in between them. Let's say this is the first layer, okay, and this is the second layer of blanket taken by you. So, and this is the person lying. Let's say this is some person sleeping, right? Person, and these are blankets. So this is the first layer of air, right? This is the first layer, and this is the second layer of air. So two layers of air trapped between the blanket. Okay. So what will happen? It will prevent our body's heat from going away to the cold air more efficiently, and hence will keep us more warm. Okay. Now, if you see the feathers of birds, that also keeps them warm in cold weather due to air trapped in between them, right? So this air has a greater role to play in keeping animals warm and humans warm during winters, right? Okay. Now you see, during the hot summer days, we use electricity to run fans, right, Mufas? So a lot of energy is used up to protect us from outside heat. From outside heat, we use lots of energy to prevent ourselves from outside heat during the summers. So we have got coolers and air conditioners to keep our house cool. And in cold winter days, we use electricity to run room heaters, right? Or burns fuels, or we burn charcoal or wood or coal to keep the house warm. So in this way, also a lot of energy is used up to protect us from the cold and harsh weathers, right? So nowadays it is not impossible, it is now no, it is actually possible to construct houses or other buildings in such a way that they are not affected much by the outer weather, right? So if houses can be built in such a way that no matter how harsh the outer climate is, we might still be comfortable in our homes. Okay, what are some of the ways to build our homes in an efficient way so that we don't experience too cold or too warm? Yes, Mafaz, any idea?
Mm,
Look, this can be done in several ways. Like one is by build by using bricks, by using hollow bricks. So what will hollow bricks do here? Hollow bricks have got air trapped in it. Or since the hollow bricks contain a air, which is a very poor conductor of heat. So what will happen? Heat will be trapped in them, right? So that will keep the houses warm during winter.
yes, sir.
Okay. So understand it like this. Let's say this is a brick being used to build a house, and there is a hollow space in it. So air is trapped inside it. Air is trapped in this. So as we know that air is a poor conductor of heat, that is, it is an insulator. Okay, so it will neither allow the heat to come from outside, and it will not allow the heat inside the home to escape. Okay, it would not allow the outer heat to enter the house, and it will not allow the house inside the wall, the heat inside the wall to escape. So that's how houses can be built in this way, by using hollow bricks to protect from the harsh weather. Okay.
Sir,
Yes, Mufas?
sir, how does sunscreen work?
How does sunscreen work?
Yes, sir.
Sunscreen basically works in this way. Let's say someone applies it on their hand. So sunscreen basically forms a layer over it. Okay, it basically forms a layer over it so that the skin is not directly exposed to the harsh sunlight. That is how it works. It basically forms a layer over the skin so that the sun rays, when falls over the skin, it gets reflected more efficiently. Okay, even if someone not applies the sunscreen, sun rays are going to get reflected, but more amount of it will be absorbed. If someone is not applying sunscreen, some, or let's say more amount of sun rays will be absorbed. Now applying a sunscreen will form a layer over it, and the rays will get more efficiently reflected. All right.
Yes, sir.
Okay, so after conduction and having discussed about the good and bad conductors of heat, next mode of transfer is going to be which one? Convection. Okay, now do tell me, if I were to transfer heat in water or a gaseous medium, how do I do that? Why the mode of convection? Okay, so you see, convection, it is basically the transfer of heat from the hotter parts of the liquid to its colder part by the movement of the liquid particles, okay, or gaseous particles. Like, see, this is a beaker, okay, and it is being warmed by some source of heat. Heat is being applied from here. So you see, the particles of water, let's say this is a water, this is a water medium here, okay, although convection happens in air also. So the particles lying below in the speaker, they will they are having more exposure to heat, they will be getting heated first. So we know that particles which are more hot, they rises above. So they will rise above, so they will come to the surface. Okay, let's say this is the level of water. Okay, listen to this carefully, Mufas. So this hot particle of water will rise to the surface, and when it will rise to the surface, it will again become cold, right, Mufas?
Yes, sir.
Because at the surface there is no heat. Okay, it will become again cold, and it will again fall down to the base. Same will be happening with all the particles. The particles which are more hot will rise to the surface, it will become cold at the surface, and again fall back to the base of the beaker. This will keep on continuing. So this creates a current that is called convection current. Convection current. What is this convection current? Movement of particles of air and gases when they are heated. Okay, got this. So this is how this is how heat transfers in a liquid medium. Same is the case with gaseous medium also. All right. So convection, we say what it is. Convection, it is what? It is the mode of transfer of heat from hotter part of a liquid or gas. Have you been taking notes of the class?
Yes, sir.
Yeah. Liquid or gas to the colder part by movement of particles. movement of particles. Now, the phenomena of using land, sea, and land breeze and sea breeze, it is also based upon convection. All right. And this via this method, that is by convection, the transfer of heat by convection can take place only in liquids and gases, because the particles in liquids and gases can move about freely somewhat. Like you see, the particles of a solid, it's very compact, right? The arrangement of particles in solid, it is very compact, while the particles in a liquid and a gas are somewhat able to freely move, right, Mufaz?
Yes, sir.
And as we saw that it is basically due to convection currents, that is the movement of particles which generates convection current, and hence due to convection currents, heat is carried on in all particles of the medium. Okay, so the transfer of heat by convection cannot take place in solids, because the particles in the solids are fixed at a place and hence cannot move about very freely, right? And it cannot also take place in empty spaces. Can you say why? Why convection cannot take place in empty spaces? By empty spaces, I mean vacuum. Yes, Mufaz. Why convection currents or by convection heat cannot transfer in vacuum? In liquids and yes, Mufaz.
Yes, sir.
My question is that why via convection heat cannot transfer in a solid medium? Or somewhat free. Okay. Look, the thing is now it requires a medium to travel, and medium is something that consists of particles. Since in vacuum there is no particles, neither particles of air, gas, or solid, that is why in a vacuum heat cannot transfer. Got this, Mafaz? So as I said that whether we take a liquid or whether we take a gaseous medium, they consist of particles. A gaseous medium will have lesser amount of particles. A liquid medium have slightly more amount of particles than gaseous. While if you take a medium that is empty, that is having no particles in it, that is vacuum, how will convection current develop in it? Is it possible for convection current to develop in vacuum?
No, sir.
No. That is why the transfer of heat in vacuum is not possible by convection. Okay. Okay, now let's talk about how convection takes place in water, that we were just talking about a little while ago. Okay, so water transfers heat by the process of convection, as we already know that. So what happens? The particles are continuously moving in water that is being provided heat. So the continuous movement generates a convection current. Okay, so it is due to the convection current, that is how heat transfers in a water that is in liquid medium. Okay, so you see it looks somewhat like of circulatory movement. Okay, it looks somewhat like a circulatory movement also. Okay, now let's talk about the land breeze and sea breeze. Okay, before we even discuss about that, let's talk about convection in air, that is also left. Convection in air. Yes, is air a good conductor or bad conductor?
Sir, bad conductor.
Bad conductor. So will it so air being a bad conductor of heat, will it transfer the heat via conduction?
Assalamualaikum, sir.
Walaikum Assalam. Yes, Chidwa, where have you been?
What, sir?
Yeah, just a minute. Okay, Arhan. Okay. I thought Jadwa is just fine. Okay, yes, Arhan, we will just begin in 2-3 minutes. All right, Arhan.
Okay, sir.
Okay. So, Mafaz, we were talking about convection in air, right? So, since air is a bad conductor of heat, that is, it cannot transfer, the heat in the air cannot transfer via conduction. That's why it transfers through convection method. Okay, so air transfer heat from hotter parts to colder parts, same as water, just we saw a few moments ago. Okay, so in order to heat air in a room during winter, we keep the heater on the floor. Will you keep the heater on the ventilator or at an elevated height?
No, sir.
No, because we know that hotter particles rises above, okay, and it generates a convection current. Okay, that's why room heaters are kept at a bottom on the floor of the room. Okay, so the air particles are going to get warmer and it will rise above and then come back to the ground again, and it will generate a convection current in all the room. Okay, so that is how heat transfer from one corner of the room to all parts of the room via convection current, right? Okay, so basically this is the process of hot air rising upwards and cold airs falling down backward. Okay, which leads to the transfer of heat on all parts of the room. All right, so in next class we will talk about sea breeze and land breeze. All right,